problem. I'm doing problem 1.7 on page 56. It says, assume that for a program, compiler A results in a dynamic instruction count of 1 times 10 to the 9th and has an execution time of 1.1 seconds. While compiler B results in a dynamic instruction count of 1.2 times 10 to the 9th and has an execution time of 1.5 seconds. Find the average CPI for the program given that the processor has a clock cycle time of 1 nanosecond. So we want CPI, which is equal to the number of cycles per second, so the inverse of the cycle time, times the number of seconds to run the program, times the inverse of the instruction count. So program on the top, instructions on the bottom. So we're going to cancel out program, seconds, and get cycles per instruction. So for A, this would be 1 divided by 1 times 10 to the minus 9 times 1.1 times the inverse of the instruction count, 1 divided by 1 times 10 to the 9th. And that equals 1.1. For B, the CPI would be 1, the inverse of the cycle time, 1 times 10 to the minus 9 times the execution time times the inverse of the instruction count. And that equals 1.25. Let's do part B. Assume the compiled programs run on 2 different processors. If the execution times on the 2 processors are the same, how much faster is the clock of the processor running compiler A's code versus the clock of the processor running compiler B? So that would be the cycle time of B divided by the cycle time of A. That would tell us how much faster A is than B. So we have the time to run a program is in seconds per program, and that equals seconds per cycle times cycles per instruction times number of instructions in the program. So that is, we'll call the seconds per cycle C times CPI times the instruction count. So if they're equal, we're going to have CA times CPI A, instruction count of A equals C of B times CPI B times instruction count of B. So CB or CA equals CPI of A times I of A divided by CPI B times I of B, and that is 1.1 times 1 times 10 to the 9th divided by 1.25 times 1.2 times 10 to the 9th. That is 0.73. So actually cycle B is faster. All right, let's do part C. A new compiler is developed that uses only 6 times 10 to the 8th instructions to run the program. So it compiles it into only 6 times 10 to the 8th instructions. It has a CPI of 1.1. That's pretty darn amazing. Cycles per instruction. It's a pretty cool compiler. What is the speed up using this new compiler versus using A or B on the original? So we want to know what is the time to run C compared to B, and what is the time to run C compared to A from part A. So we have to get TC, which would be, again, the number of seconds for a cycle times the number of cycles per instruction times the number of instructions in the program. So that would be 1 nanosecond times 1.1 times 6 times 10 to the 8th, and that is 0.66 seconds. So TB over TC is 1.5 divided by 0.66, and that's 2.27. And then TA over TC would be 1.1 over 0.66. That is 1.67.